These are the notes for Algebra 2, Section 1.7, pages 51 through 55 in your textbook. It deals with absolute value equations. Now, an absolute value can be defined as the distance a number is from 0 on the number line. Since x and negative x are the same distance from 0 on the number line, their absolute values are the same. In other words, if I look at the distance between x and negative x on this number line, they take up the same amount of distance. The distance on the right is equal to the distance on the left. So the absolute values of x and negative x, the absolute value of x and negative x are equal. Now, what does that mean for us? Well, when we have an absolute value equation, what we've got, like for instance, the absolute value of x minus 3 equals 4. What we're really saying is the distance between x and 3 is 4. So the distance between x and 3 is 4. Okay, so that's nice, but what does that mean for us? If I had 3 on the number line, I could move 4 spaces forward or 4 spaces backwards, and both of those distances would be equal. So I could have 3, 4, 5, 6, 7, or I could have 3 minus 4 is 3, 2, 1, 0, negative 1. And both of those numbers are a distance of 4 from 3. Now, what that means is that x minus 3 equals negative 4, and x minus 3 equals positive 4. So when we're working on an absolute value equation, we have to keep that in mind. We can add 3 to both sides here, and we get x equals negative 1. We can add 3 to both sides here, and get x equals 7. And since both of these distances are equal, both of these numbers are solutions. So when we're solving an absolute value equation, we end up having to solve more than one equation. For instance, if I had the absolute value equation, the absolute value of x minus 5 equals 7, I can't just solve x minus 5 equals 7. It would be nice, but that's not the only equation I have to solve. I also have to solve x minus 5 equals negative 7. So I have to take what's on the right side of the equation and change the sign. Now when I solve these equations, we've done this before. Add 5 to both sides. We get x equals 7 plus 5 is 12. So one of my solutions is 12. On the other side, add 5 to both sides, and get x equals negative 7 plus 5 is negative 2. That is my other solution. Both of these numbers are solutions, because if x is 12, it still creates a true equation. If x is negative 2, again, it's still a true equation. Alright, so let's look at something slightly more complicated. I have the absolute value of 5x minus 10 equals 45. Well, again, I'm solving two separate equations. I have to solve the equation 5x minus 10 equals positive 45, and I have to solve 5x minus 10 equals negative 45. Solving the first equation, I start by adding 10, since this is a two-step equation. I will always add or subtract first, and I get 5x equals 55. After that, Since I'm multiplying x by 5, I divide both sides by 5. And I get x equals 11. That's one of my answers. I still need the other answer. So on the other side, I have 5x plus 10, same steps, right? I'm going to add 10. I end up with 5x equals negative 35 in this case, because negative 45 plus 10 is negative 35. And just like before, I divide by 5. And I get x equals negative 7. Both of these are solutions to this equation. Notice that the steps that I used to solve these equations were the same. That may not always be the case, but most of the time it will be. You can use the same steps to solve the equations. However, there's one more thing that we have to sort of keep in mind when we're dealing with these absolute value equations, and that is that when we're solving them, we can sometimes have what are called extraneous solutions. An extraneous solution appears to be a solution. So when we work out the equation, we end up with a couple of different solutions. But an extraneous solution will not actually satisfy the original equation. If I plug the extraneous solution into the original equation, it will not be true. Let's see an example of that. We want to solve 2x, the absolute value of 2x plus 12 equals 4x. Well, we have to solve two different equations. We have to solve 2x plus 12 equals 4x, and we have to solve 2x plus 12 equals negative 4x. Both of these equations are needing to be solved. Let's start with the equation on the left. I have 2x plus 12 equals 4x. I want to move all the x's to be on the same side. So what I'm going to do is subtract 2x, because all the x's need to be together. And I get 4x minus 2x is 2x. So 12 equals 2x. I can divide both sides by 2 to get x by itself. And I get x equals 6. On the other side, I've got 2x plus 12 equals negative 4x. And again, the same idea. I want to get all of my x's to one side. So I can do the same thing. I can subtract 2x. This time, when I subtract 2x, I get 12 equals negative 6x, because negative 4x plus minus 2x is negative 6x. Again, the same steps. I divide. This time I'm dividing by negative 6 instead of 2. Divide both sides by negative 6, and I get x equals negative 2. We need to check to make sure that both of our solutions actually work. So that is going to be our next job. We're going to take each of the answers that we got, and we are going to plug them into the original equation. Here's what happens. I've got the absolute value. I'm just doing the equation on the left. The absolute value of 2 times x is 2 times 6 plus 12 equals 4 times x, so 4 times 6. 2 times 6 is 12, so I've got 12 plus 12 equals 24. Well, the 12 plus 12 is 24, so the absolute value of 12 plus 12 is 24. The absolute value of 24. Well, the absolute value of 24 is 24. So these two are equal. 24 does, in fact, equal 24. So that is a solution. It works. It's not extraneous. On the other side, I need to do the same thing. Now, a common mistake to make will be to plug your x value back into the equation you started with. But that's not what we're doing. What we're doing is plugging the x value that we got into the original equation. So we need to plug the x value into the original. 2 times negative 2 for x plus 12, the absolute value of that, equals positive 4, not negative 4 because we're going to the original equation, 4 times negative 2. Well, negative 2 times 2 is negative 4, so I've got negative 4 plus 12 equals negative 8. Negative 4 plus 12 is 8. So I have the absolute value of 8 equals negative 8. But the absolute value of 8 is 8, not negative 8. These two are not equal. So this is not a solution. Negative 2 doesn't work. This is extraneous. And when I'm asking for answers, I simply ignore x equals negative 2 because it's an extraneous solution. It doesn't actually do anything. It doesn't work. Alright, I want you to solve the equation, the absolute value of 2x plus 5 equals 3x. Pause the video, solve the equation. In just a moment, unpause the video after you're done, and we'll see what the solution or solutions are. Alright, so when I worked this out, I have to move this down a little bit. When I worked this out, I had to do two separate equations. I had to do 2x plus 5 equals positive 3x, and 2x plus 5 equals negative 3x. Solving the first equation got me 5 equals x. Solving the second equation got me negative 1 equals x. Plugged in my first solution, 5, into the original equation, got me 15 equals 15. 2 times 5 is 10, plus 5 is 15. 3 times 5 is 15, so this is a solution. 5 is a solution. On the other side, I had to plug negative 1 into the original equation. Forgot a parentheses there. I plug negative 1 into the original equation. I have negative 2 plus 5 equals negative 3, which breaks down to 3 equals negative 3, which is not true. 3 does not equal negative 3, so the solution x equals negative 1 is extraneous. It doesn't work when we plug it into the original equation.